All right, so today we're going to look at transformations and graphing of absolute value, which is just like when we did transformations of quadratics. So if you have your foldable in front of you, we're going to look at first what a, h, and k are, which is the same thing as quadratics. So the a value, it does two things basically. So the first thing it does is, and I'm going to color code these so we know the a value. That is going to stretch or compress. So remember, if the a value is, or really the absolute value of the a value, if it is bigger than 1, then it is going to be a stretch. If it is really between, if the absolute value is between 0 and 1, then it is going to be a compress. And then the other thing that it does is if that a value is negative, then it will make it reflect across the x-axis. So that is what the a value will do. The h and the k, if you remember, h comma k is our vertex. All right, so this is the vertex. And also as far as transformations, what happens is the h value is going to move it either left or right. And when we change the k value, that's going to move the graph up and down, up or down, I guess I should say, not and, up or down. If it's positive, it'll move up. If it is negative, it will move down. As far as the h value goes, remember anything in parentheses is the opposite of what we see. So since there's a minus, and I know there's not parentheses, but it's the same rule with absolute value bars. The formula has a minus, so think opposite. All right, so first we're going to look at what the parent function of a absolute value looks like. So this is the most basic equation. F of x equals the absolute value of x. So I want you to think about what your vertex is. So the number in here with x, there is nothing, which means the x value of our vertex is 0. And I'm going to put that in the middle of my table. And then the k value, there's nothing being added onto the end. I'm just going to keep this. So the k value is also 0. So this is the vertex, and I'm going to go ahead and I'm going to plot that point. And I'm going to write that here, 0, comma, 0. That was my vertex. So from the vertex, I'm going to get some more points. So I'm going to go each direction. So I'm going to go in the negatives here, and then I'm going to go 2 units the other direction. So now what I'm going to do is I'm going to find if I plug -2 into that formula, or that equation. So the absolute value of -2 equals what? Absolute value turns everything positive, so it equals a positive 2. If I plug a -1 in, the absolute value of -1 is positive 1. If I plug a positive 1 in, that's going to also give me 1, and a positive 2 is going to give me 2. So I'm going to plot those points real quick. So -2, 2, -1, 1, positive 1, 1, positive 2, 2. And then I'm going to draw this. So this is the parent function of an absolute value. All right, so now let's look at what happens when we transform. So if we change things like the a, h, and k value, how is that going to change what the graph looks like? So the first one, all we're doing is adding 1 onto the end. So what does that make our vertex? In the absolute value bars, there's nothing with x, so the x value is 0. And the k value is 1. So that's going to give me my vertex at 0, 1. And again, I'm going to put that in the middle of the table because to get more points, I'm going to go the opposite direction. All right, so I'm going to plot the vertex at 0, 1, which is right there. And then if I plug in a -2, it would look like, I don't know where I'm going to do this, right here, I guess. I'll erase it in a second so you don't have to write this down, just watch. If I plug in a -2 into the equation, the absolute value of -2 is +2, 2 plus 1 is 3. So -2, 1, 2, 3 is right there. If I change that and I plug in a -1, -1, the absolute value of -1 is 1. 1 plus 1 is 2. So I have the point -1, 2. If I plug in a +1, the absolute value of +1 is 1. 1 plus 1 is 2. If I plug in a +2, the absolute value of 2 is 2. 2 plus 1 is 3. So I've got the point 1, 2, and 2, 3, and I can draw my new graph. So comparing this to the first, our parent function, if I'm just looking at these two graphs, all that happened was the graph did what? It shifted up 1 unit. And we know that because we know that the k value, because that's all that changed right here, was the k value of 1. All that does is move the graph up 1 unit. So right there where it says transformation from the parent function, go ahead and write up 1 unit. All right, so let's look at this one over here. So first thing I'm going to do is find my vertex. So the vertex, there's a -2 in the absolute value bars, so I got to think opposite. So my x value is really a +2. There's nothing being added onto the end, so my y value is 0. So my vertex is at 2, 0. So to get more points on this one, to go after 2 comes 3 and then 4. Before 2 is 1 and 0. So now I'm going to plug 0. If I put a 0 in right here, 0 minus 2 is -2. There's still a negative out in front. So the absolute value of -2 is 2, but since there's a negative in front, when I plug 0 in, my output is a -2. So now I'm going to plug in a 1. So if there's a 1 here, 1 minus 2 is -1. Negative out in front is going to give me -1. If I plug in 3, I should just really cross it out. So 3 minus 2 is 1. Negative out in front makes this a -1. If I plug in a 4, 4 minus 2 is 2. The absolute value of 2 is 2, but the negative out in front makes that a -2. So now 4 minus 2 is 2. I'm sorry. So I'm going to plot these points. So 2, 0 right here. And then I'm going to plot all my other ones. 0, -2 goes here. 1, -1 is here. 3, -1 goes here. And 4, -2 is right there. And draw my absolute value. All right, so that is the transformations taking place. If I have a negative out in front, notice what happened to the graph. It no longer opened up. It reflected across the x value, or the x-axis, and then it moved right 2 units. All right, so that's that one. So now let's look over here at this one. So first thing, my vertex is at 0, and then the k value is -1. So 0, -1 is my vertex. I'm going to put that in the middle of my table. I'm going to go ahead and plot that. So to get more points, I'm going to go on each side of 0 here. All right, so let's say I plug in a -2. So the absolute value of -2 is 2. So you have 2 times 2 minus 1. 2 times 2 is 4. Minus 1 gives you 3. If I plug in a -1, the absolute value of -1 is +1. 2 times 1 is 2. Minus 1 is 1. Plug in a +1, the same outcome, right? I'm going to get 1. If I plug in a +2, it's going to be the same outcome as when I plugged in a -2. So that's going to give me 3 here. All right, so -2, 1, 2, 3, -1, 1, 1, 1, and 2, 3. So this time it definitely was stretched, which we knew it would because the a value changed to a 2. So writing our transformations, the a value of 2 made it stretch by 2. And then we had a k value of -1, which moved the graph down 1. All right, last one. Find the vertex first. Opposite for the x value, so that's a -2. And then the k value is 1. So my vertex is at -2, 1. Plot that right there. All right, going on each side of that vertex to get more points. After -2 comes -1 and then 0. Going further in the negatives, we got -3 and then -4. All right, so let's plug in here. If I plug in a -4, -4 plus 2 is -2. The absolute value of -2 is 2, so you have 2 plus 1, which is 3. All right, so let's see when I plug in a -3. -3 plus 2 is -1. The absolute value of -1 is 1. 1 plus 1 is 2. If I plug in a -1, -1 plus 2 is 1. The absolute value of 1 is 1. So you have 1 plus 1, which equals 2. And you should start to see the pattern. When I plug in 0, I'm going to get a 3 out. So let's plot these points. -4, 3, -3, 2. I already have my vertex, -1, 2, and then 0, 3. Graph it. Oh. All right, so the transformations that took place, I had an h value, so that think opposite, so it looks like a +2, but it's really making the graph move left 2, and you can see that our graph literally went to the left of the y-axis. And then the +1 at the end made it move up 1. All right, so there's the notes on transformations. You're going to click on the second video to watch how to quickly graph these by hand without making a table first.